So, function behavior. This is a chart we've made a bunch of times, right? If your first derivative is positive, which means above x-axis, then your graph of your function is increasing. If your derivative is negative, which means below x-axis, then your original function is decreasing. Okay. For concavity, we look at second derivative if it's available, right? Second derivative is positive. Then our graph is concave up. If the second derivative is negative, then the function itself is concave down. And then this sort of translates here. If the second derivative is positive, then the first derivative is increasing. And if the second derivative is negative, the first derivative is decreasing. So sometimes we have questions where we have to answer from the first derivative, right? Because that's all we've got there. That's a huge one. We need to know that. I see a lot of you drawing it on your tests when you run into something of this nature. So I think most of us have got that down, but it doesn't hurt to review. Let's talk about all the theorems. Okay, these I think are sometimes kind of confusing and hard to keep straight. Okay, intermediate value theorem. If a function f is continuous. Okay, intermediate value theorem, only continuous. Doesn't matter if it's differentiable. On the closed interval from a to b, and d is a number between f of a and f of b, then there exists at least one number x equals c in the open interval a, b such that f of c equals d. Sometimes I think it's helpful to draw a little picture for this. If I have a and b here, and I've got some sort of function like this, that's not the best function I've ever drawn, especially for this. Let me try it again. Let's draw something like that. This is just telling us that if you know f of a is here, and f of b is here, then if d is right here, then there's got to be a place where your function equals that. It's just like, I think the example that I use when I introduce this is that somebody has gained weight, and they say they've never weighed 200 pounds in their life, but they weighed 198 here, and they weighed 205 up here, right? Like, if that's continuous, then they weighed 200 pounds, right? So it's just it's not even really a calculus argument. I think the reason that it's in calculus is because you use limits to show that it's true, but it's just you were here, you're up here, so you had to pass what's in between, right? Mean value theorem is that if a function is continuous on the closed interval AB and differentiable on the open interval from A to B, then there exists a number C in A to B such that f prime of C equals f of A. Well, usually we do f of B minus f of A over B minus A. And I like to think derivative equals slope between endpoints. Okay, so if you're thinking about the graph for this one, you can draw pretty much the same graph. If my slope between the endpoints looks like this, I didn't draw the greatest graph here either. There's got to be somewhere where that derivative, that slope of that tangent line is the same. This is the example where I showed you guys the German speeding ticket that my husband got, where if you're going from point A to point B, and it only takes you this time, your average rate of change is a certain amount, we know your actual speed was that at least once. There. Okay. Mean value theorem is derivative equals slope between endpoints. It is different than whenever they ask you about the average value of a function. The average value of a function, they could ask for the mean value of a function. Average and mean are interchangeable words, right? I'm hoping they don't, because mean value makes you go mean value theorem like immediately. But average value is 1 over b minus a integral from a to b f of x dx. This will give you the average value of f of x. Whatever function, if they're asking for average velocity, do this formula with velocity. If they're asking for average position, do this formula with position. If they're asking for average acceleration, do this formula with acceleration. If they ask you for average number of people entering the building from here to here, do this formula with the number of people entering the building. L'Hopital's rule. Here, remember with L'Hopital's rule, we want to say if the limit as x approaches a of the top equals 0, I'm going to put or infinity. Technically, they could give you infinity over infinity here instead of 0 over 0, but most of the problems are 0 over 0. And the limit as x approaches a of the bottom equals 0 or infinity. Okay, so with L'Hopital's rule, we have to show that the limit of the top and the limit of the bottom are both 0. We want to state them separately. We don't want to use equals 0 over 0 because it's mathematically incorrect and we might lose a point. But if that is true, then we can just do the limit as x approaches a of f prime of x over g prime of x. There. Okay, questions here? So take the derivative, take the derivative of the top, derivative of the bottom, plug our values in. Fundamental theorem of calculus is that whenever, I should have put both, there's like 2 versions of this. The one I've put here is that whenever we integrate lowercase f, we are going to get, I'm going to do it in 2 steps. We're going to get capital F of x, which we evaluate from A to B. Lots of times people skip that middle step, which is fine if you do, which means you'll get F of B minus capital F of A right there. It is basically how you evaluate definite integrals. I really should have put the other version of this. That is where you take the derivative of the integral from a to how do I want to do that? I'm going to put u of f of x dx. Okay, so when I take the derivative of an integral, right, the main thing that the fundamentals theorem of calculus figured out was that derivatives and integrals are inverses of each other. So they pretty much undo each other, but I've got to take, like, this has to be a number. So it doesn't matter what that number is, what the a is right there, but it has to be a number. And then you take the u, and you just sort of plug it in right here. So you will have f of u, but you must multiply it by u prime, right? So it's like a chain rule there. So if that's just an x, you're just going to get f of x. But if you have like 2x, you'll have f of 2x times 2, right? So you have to multiply by that derivative, do a little chain rule there. That is like the other version of the fundamental theorem of calculus. Okay. Derivative of an inverse. You're not going to see a ton of these, but you'll see it, right? And you guys are pretty good at it while we were doing it. I bet we've forgotten the formula. It is 1 over f prime of f inverse of x. There. So it's almost backwards. You're doing f inverse prime. Like the inverse comes first and then the prime, so it's f prime f inverse here. And you'll see some of these on the review stuff that we're doing. Okay. Rather than doing like some sort of formula for Riemann sums, I just gave you a table, and we're going to do like an example problem sort of for these. So if I have to do a left Riemann sum for this table, right, I will look at the width of the rectangle times the height, which will be my left endpoint. So like for this first one, I'll do 0 to 3. That is a distance of 3. And then I'll multiply that by the left endpoint, which will be A. And then I'll do my next rectangle. From 3 to 4 is 1. So I have 1 times B. And then I'll do 4 to 7. From 4 to 7, that's 3 again. And I'll use the left endpoint, which is C. Not much changes if I'm using the right endpoint. What is it going to look like if I use the right endpoint? I'll have, still the distance is 3, but what letter do I use here? I use B, because I'm thinking like from here to here, and then I do the right endpoint. I'll do from here to here, right endpoint. Here to here, right endpoint. So that would be, let's do this one in red, 3B plus 1C plus 3D. Okay. Trapezoidal sum. Let's skip down. Skip down here. Area of a trapezoid. What was the formula for the area of a trapezoid? That is a triangle. Let's put it over here. That is 1/2 base times height. Here. Yes. So it is height times half of base 1 plus base 2, or we talked about it just being height times the average of the bases, right? So height times base 1 plus base 2 divided by 2. I'm going to write that out. Height times average of bases. You also might use like 1/2 h times b1 plus b2. Perfectly fine there. I do think this like height times average of bases helps you remember it a little bit better. So if we're doing up here, remember in a trapezoidal sum, the height is really a little more like the width because all your trapezoids are like over on their sides, right? The parallel sides are the bases. So it would look like this. You'll have height, which would be 3 for that first one. And then we would multiply by A plus B, the two bases, over 2. That'd be your first trapezoid. Then we would have 1 times B plus C over 2. And then we would have 3 times C plus D over 2. So now I've got the spacing off on everything. It's not on the same line as it should be. Okay, questions there? For midpoint Riemann sums, if we do this midpoint Riemann sum with 3 equal subintervals, midpoint Riemann sums, you're going to have more points than you really, like it looks like you need for 3. But that's because you're doing, here's your first jump, here's your second, here's your third. Now this particular problem, I gave you one where all the intervals were the same length. So from 0 to 4, that is a distance of 4. So you would have 4 times, you multiply that by the middle point, which would be h. And then you'll do your next one, from 4 to 8 is also 4, and multiply that by your middle one, which would be j. And then here we'll get 4 times L. Inconsistent with my use of parentheses. You can use them or not. It doesn't matter. It just looks ugly whenever I halfway do it. Okay, questions there? We were good at those when we were doing them. We haven't done many in a while. So you'll get some practice with them there. So we filled in area of a trapezoid, filled in area of a triangle. What's the area of a circle? Pi r squared. What's circumference of a circle? 2 pi r. Or you can do pi times diameter, whichever one makes more sense in that particular problem. I want you guys to get started on your group test, and we did it's been pretty recently, we did a practice formula sheet like that was just for areas. So I am going to skip filling this in right now. We may or may not go back to it there because you do have